and solve this problem in geometry. For those watching, you can pause first and then give it a try to solve this problem. Translations and rotations. Okay.
Also, it is February 14th.
Yeah. Happy Hearts Day. Happy Valentine's. Is the day of love.
Celebrate. Okay, so the main theorem here is, let's say this is a center of the half turn. So this is XC, YC. I will be using for now analytic geometry take.
Yes. So
So here
we'll be
is
presenting two solutions. Because there's
yes.
solution number one above.
Min. This is what wait. Maybe a more creative lead. Uh we find A. So because it's a half turn, the basic definition that follows from it is that these are equal, and C is the midpoint of whatever this is, A prime. So what is this? Let's say that let's call the coordinates x prime and y prime. What's x prime and y prime in terms of x, y, and the center coordinates? No, this x because the uh midpoint formulas, maybe midpoint formula or whatever. The formula that states if you just add the coordinates of each endpoint of a segment and then take the mean or divide by 2, you will get the coordinates of the midpoint. So just moving backwards, you can see x prime is equal to 2x minus. So the problem states that we need to move A first successively by O1, O2, O3, O4, O5. So let's say the new piece uh, begins with the solution 1. Solution I will be less confusing. So if A, the very original starting point, be at 0, 0, the origin, and O1 is x1, y1, O2 is 2y2, etc. So first we move it by the very first rotational center O1. So x prime first prime movement. Because I picked the first original point to be the origin it will make life much simpler. So now next. So as you can see, I'm just constantly feeding. I'm just constantly feeding the found previously found coordinates of the earlier already rotated point. Just keep feeding it into this formula. I will just screenshot this. So it means so it means after 5 rotations, this is the result that comes out. Ah, okay. Funny. History came up. There, okay. Oh, come on then. When Jamboard is done. Okay. Pass this on to the next page. Sure. So actually, it is exactly the same, just reversed. So A prime will be 2x5. Just imagine if x1 from here became x5, x2 became x4, x3 stayed the same, and then vice versa. So I will not repeat what I did earlier because it will take too much time and space. So the final, by just predicting what happened earlier, by replacing 1 with 5, get, and 4 with 2, 3 stays the same, 2 becomes 4, and then 1 becomes 5. Why am I putting equals? Did I just put an equal sign for all of them? So let's compare this with the one earlier. So x5 is positive, x4 is negative, x2 is also negative, x3 is negative, x1 is positive, y5 y5 is positive, and y1 is also positive, y2 negative, y3 negative, y4 negative. So if we express this, it's exactly the same as earlier. So they are the same. So it means the coordinates of the eventual endpoint, which is A5, are exactly the same. So this one is actually P, and this one is Q. So that's the analytical geometry proof.
Yeah.
And,
Nice.
really, all that there is to it, and the analytical geometry proof is simply using the midpoint theorem and just keeping on doing it brute force. So now this is a more sleek solution by using purely geometry, no coordinates. So in the earlier video, there was translate half turn plus has to half turn plus a half turn is equal to a translation. So obviously a translation plus a half turn is a half turn because eventually those are just imagine your clone went to Jamaica. Did that specific body go to Jamaica? Yes, it did. So here you can see this clone of this triangle has been half turned. So imagine we just erase this. Of course, then this image is a direct half turn of the very original image. So half turn plus translation equal to half turn. So wait, I'll just put it here. So now this is a rather rare notation, but we will now be using it here. So
Better if you read the translation over.
uh, And one. Read the overall transformation as a function. Then, so it's another translation. So this is equal to P is equal to P. So F is a big half turn because half turn about O1, half turn about O2, O3, O4, O5. So here, half turn about one, and then another one. That's an overall translation. Half turn about one, and then another one. So this is translation, another translation, and then a half turn. So that is a half turn overall. So now what if it's the from O5, O4, O3, O2, and O1? It's exactly the same. 1, 2, 3, 4, 5. So 1, 2, 3, 4 entire translation, and then another half turn. So that's a complete half turn only. So FA half turn. So if we nest the function f again, so this is function of p. So what we did is some point some point we don't know. So it went to p because that's a half turn overall. And then we take that same function of p around this same point. Where else could that possibly go to? That's back to a. So f of p is equal to e. So because of this, p is the inverse function of a. So the inverse function is when, say, there is a function like tangent of x equals something something. When you plug in this unknown object into the inverse, you should get x. So in this case, we have f of p equals a. The inverse function, when you put in a, it should get p. So that's true. So let's say there is this point 1, 2, 3, 4, 5. So 2, 3, 4, 5. Unfortunately, uh, the more straightforward. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here it can put here. So this is points, the points of rotation. This is some point say M. There's another point N. So when it goes from M to N, it's the master point OX. The entire manifestation of the entire half turn So M if it goes through this direction, going through O1, O2, O3, O4, O5 to N. So so that's the function of OX to N. But now, what is the function of going half turns from O5, O4, O3, O2, O1? So apparently we don't know what happens if we put M into this function. Although the problem states that in some way it should be N. We're not sure of that, but we are sure that if we plug in N into that function, we'll go about O5, O4, O3, O2, and O1, all the way back to M. So we are sure that the inverse function, I don't know, not really the inverse function, the function the function going back O5, O4, O3 to O2, O2, and O1 will exactly reverse everything and go back to M. So imagine the function of M goes to N. Now the another function of N goes to M. So if we nest this G, F, M, it all goes back to M because M will go to N and then N will go back to M. So this means G and F cancel. So it means G and F are inverses. So similarly for this problem, F and G must be inverses.
Nice.
So since G and F are inverses, G of A is equal to Q. So G of A is equal to Q. F inverse of A is equal to Q. So F of A should go to 2, 4. Wait. So this is F. Why did I use -1 now? F prime of A is equal to Q. Wait, no. It should be. I was using the wrong notation. That's why. I was correct. It should be -1. So P is equal to the inverse function of A. And then Q is also equal to the inverse function of A. So therefore, Q is equal to, that's it. Or P is equal to Q. So show that P is equal to Q. This actually is part of a different problem. It's no longer part of the actual question. But show that P is equal to Q. Here, we show that the coordinates are the same. Now here, we show that the function in both directions is the same. So therefore, they end up in the same place. So thanks for watching.
Thanks for watching. Happy Hearts Day. Happy Valentine's Day.
Bye.